Good evening, and thanks for joining tonight's TI Technology webinar hosted by Texas Instruments, where tonight we're going to take a look at some math and some activities, and they might incorporate, I'm getting my taboo buzzer ready, the upcoming winter games. Tom, maybe? Am I allowed to say upcoming winter games? Well, my name is Mike Houston, and I'm the moderator for this event. I teach algebra and calculus near Pittsburgh, where I use TI technology to make those tough to teach, tough to learn concepts accessible to all my students. And tonight I'm excited to be joined by the man, the myth, the legend, Tom Reardon. Tom, thanks for joining us tonight.
Hi, Mike. Good to be here. Hi, everybody.
Tom, would you mind talking through the plan for tonight?
Sure. Okay, the agenda, provide activities, background, and data about winter sporting events, and make mathematical connections to this information. I'm happy to report that all materials are available for both the TI-Nspire and TI-Nspire platforms. There'll be some data about China and Beijing, and Mike is going to have a webinar drawing at the end.
Awesome. As a reminder, the session is being recorded, and we'll provide a link to the certificate of attendance at the conclusion of the webinar. All right, Tom, without further ado, let me give you control and have you share your screen.
Okay, and all right, so this is what I'm going to be doing. There are also I'm going to share two extra activities because of the weather recently, wind chill formula, and also families of functions. All activities and materials are available at this website, and I think Mike's going to put that in the chat for us. It is case sensitive. It's all lowercase, even the numbers. Just kidding about the numbers. And then if you stay till the very end, I have a bonus activity for you, okay? So see what that is. So this is what all the materials that are on the website, they'll make a lot more sense once you've gone through what we've done tonight. But I just wanted to prove to you that it's both for the 84 and the Inspire, okay? All of them, everything there is for both of them. Quotes, I like to start off with quotes. I found this one. I know we won silver, but it really just feels like we lost gold. And this is because we're going to be talking about the Winter Olympics. And I won't even attempt to try to pronounce that name, but I think you can feel her sentiment. And I thought this other next quote I thought was appropriate because of the date. The time is always right to do what is right. And that was from late Reverend Martin Luther King Jr. So welcome. So a couple of disclaimers or asides. We were not allowed to use the word Olympics in the description of this webinar, so that's why it was called the Winter Games. Just like we can't use the phrase Super Bowl. I think that's a copyright issue or something. So we're also not allowed to use the Olympic rings, but I found a way around that, and you'll see that a little bit later on. So a quick poll, Mike is going to put out a quick poll, and I'd like to know whether you are mainly an 84 person, an inspired person, or both. You just vote for one of those. I just want to get an idea of what my audience is. Even though I'm for both, we'd like to know what the polling is showing. So please vote on that. It shouldn't take long, A, B, or C, to do that vote.
And Tom, I just want to jump in real quick. So if you're new to our webinar,
it's through the poll, not through the chat.
Right. Okay? Yep. So we're going to use
coming through
the poll feature on the right side of your screen, unless you're on a mobile device, which I don't think you don't have access to.
All right, so my goal is to create math activities that students hopefully would want to do. That's what we would always like to do, that teach some good mathematics, but also create interest in the Winter Games in Beijing, or vice versa. The Winter Games may spark some interest in them paying attention to mathematics that deal with that. The games are from February 4th through February 20th, in case you're not aware. And I thought we'd start off with a little bit of information about Beijing and China population. Um, so, uh, so here's some data that I thought was kind of interesting. I looked up the largest cities in China by population, their top 10. They're huge, just huge, okay? And then I looked at the top 10 cities in the United States. Wow. I mean, you can't even fathom a city three times larger than New York City, okay? Um, and our 10th biggest city is 1,000, or 1,000,000 rather, and this one's 10 million. So just kind of crazy. And I have no math activity about this, but I just think it's a good idea to get that perspective, okay, there. So what I did want to look at was Beijing population, and this is the website that I used. And there is data here. What you had to do is click on here, and it would give you the year and the population. So I went and hand captured every 5 years from this graph. And I put those values into lists. List one has 1950 to 120, which is the year 2020. It's always a good idea to use small numbers when you're doing regressions. And the population is in millions, but rounded to the nearest thousand. So this would be 1,671,000 and so on. Okay. So this is the activity that I created just for you guys for this evening, okay? And I thought I'd just go through and do it with you on the 84. Then at the end, I will show it to you on the Inspire as well. So um, the best way to get data into a calculator, as far as I'm concerned, is not to type it in, but to have it in a program, and then you execute the program and you've got it. So I'm going to go ahead and run the program. In fact, let me maybe use my smart view to um, do this. Let me hook it up here. Uh, I'm using what's called the Smart Pad app, which is one of my favorite things to do, and I can use my 84 CE to run my smart view. So I'm going to go down to Beijing Pop and execute this program. And it says automatically places the population in millions into lists, enter to continue. And it explains, what year, what the calculations are for that. Okay. So that no surprises there. And again, these are just taken clips from the actual activity that you have access to. All right, next it says, let me make this view so that it's always in front so it doesn't keep disappearing on me. It says, look at the data in list L1. So let's go stat and edit. And there's the data in L1 and L2 and some other data in L3, 4, and 5, but mainly interested in L1 and L2. So it says set up a stat plot. So second y equals, and I'll turn it on. Scatter plot. Make this a little bit bigger so you can see better. X list is L1, Y list is L2, and I like that mark the best. So I'll just pull that off there. And used window settings. Okay, so I need to change the window. And remember, on a window, there are several that are possible, several good windows and several that are terrible. For this one, I decided to go with X-min being 45 and X-max being 130. And that would be in 1945 to 2030. I want a little bit before and a little bit after the data. And maybe show every 10 years. Y min, remember that's the population, it goes around 20 some million. So I'm going to go -5 so I have a place to trace up to, let's say, 25 million in steps of 5. So this is the window that I chose to use on it. And let's see what's next. So it says decide what curve. So I guess we should go ahead and plot. Whoops. Don't want that. So I should go ahead and graph. And it says decide on what type of curve will best model this data. This is where I want my students to talk. I want them to know the parent functions. We'll talk about those parent functions a little bit later. But for here, there are several that are possibilities here. I mean, a quadratic would be okay, kind of a flattened U, and maybe a cubic. A quartic is usually very good, and maybe exponential, maybe logistic. So I said try one or two different regressions. So let's go ahead and try an exponential first. So I'm going to go back to the home screen and stat, calculate an exponential regression. The data is in L1 and L2, and we'll store it in alpha trace Y1. And then I'll press calculate. And notice it's not giving me the data that I want. So I'm going to go back to mode, and under stat diagnostics, I can turn on the diagnostics right here. Okay, right there on there. So I'm going to go and do that. And then I'm going to go back and run that regression again. And this time it does give me an R squared and an R, correlation coefficients. And they don't look too bad. Let's see what the graph looks like. And better than I had anticipated. Let's say say that way. Okay, better than I anticipated. A little shaky here, a little shaky here, but as far as maybe predicting the future, maybe going up a little faster than we'd like, but not too bad. Let's try another one. I'm going to try a quartic this time. So I'll go back to Y1, and I'm going to turn off Y1. And now I'll do a stat calculation and a quartic, L1, L2. I'm going to put this in Y4 to remind me that it's a fourth power. And wow, that R squared is awfully good. Okay, awfully good. Let's see what the graph looks like. Wow. And so you can see it kind of caught a lot of those points. Okay, pretty good. Okay, so I'm going to stick with the quartic for right now. It looks like the best fit, though it looks like it might be curving down for extrapolation later on, but we'll stay with it for right now. And let's see what's on next. Using the trace feature, I would want the students to be able to compare the actual with expected from. So I'll go ahead and press trace, and you'll notice I'm on the plot. And so let me go to maybe whatever year this is. This looks like it's 1980, and that's the actual population, 5,366,000. Okay, and let me now jump to the modeling equation and also trace to 80. I can just type in 80 and see that they're in the 5 million. The nearest million, it's pretty good. This is 5,078,000, 5,366,000. Not too bad. And we can have them go through and do that. That's a good idea, I think. But then I'd also like them to look at some populations at certain years and calculate the percent error, see how far off they are. So it says to do this for 1965. So let me again go back to the data and go down to 65. And that's the actual. And then I can go ahead and go up and then trace again to 65. And I'd like to go ahead and find what's the percentage error on this. How bad, how far off are we? So I will go back to the home screen, and alpha xt theta n gives me my nice looking rational template. 100 times the quantity of, it's going to be my expected, or my experimental, I should say. And my experimental is right here. And I'll round to 3 decimal places like we did here. So that would be 4.334 million minus the actual 4.582, and then compare that to the actual. And we can see we're about 5.4% off. The negative indicates that it's lower than it should have been, okay? And I'm really big on having my students calculate percent errors and so on. I asked them also to do it in 2020, but I'm going to skip that. It's in the teacher notes and so on how to do that because I'd rather get to something a little bit more interesting. So how about if we predict what the year 2022 is to the nearest thousand? And there are a couple ways we could do that. One is we could go to the graph and trace to on the modeling equation to the year 122, and we can get the value there. Or we can go off to the home screen, and this is in Y4, and I can actually bring up Y4 and evaluate that at 122, which is the year 2020. Oh, I want to go, yeah, 122, right? And notice I'm getting the same answer, but by using function notation. And I think both of them are very, very, very good to do that. It says how close do I expect that to be? Based on this graph, I expect it to be pretty good. Okay, I would say it's pretty good, especially with all those. Well, let's go ahead and look at the percent errors because I think no, that's not on this one. Sorry. So let me just pause there for a minute. Mike, are there any questions or anything I need to go back over or anything at all?
Nope, Tom, so far looks good.
Okay. You know what? I lost my speaker, so I didn't. Was there anything there, Mike? Sorry.
We're good, Tom.
Okay. All right. Good. Thank you. All right. But if you do have some, let me know. All right. So I'd like to show this activity for those of you who do Inspire. Okay. What this would look like. So I did bring those up, and these are always a trouble to get there because this thing gets in the way. Uh, so let me just go ahead and bring it up this way. So here's the student activity for this, okay? And you can see it's the same questions that I had for the 84. They're just going to be done differently. So I'm going to show it to you, show you the teacher notes and solutions that they're there for you. And you can see they're all Inspire screens, okay? And notice I did not use the data and statistics part. I just used a stat plot on the grapher. I show the exponential, show the quartic, show the graphs, and so on. So if you're interested in this activity at all, no matter which platform you use, hopefully that will work. And I see Jay Schiffman's here. Hello, Jay. I haven't seen you for a while. Glad to see you came. And then for the Inspire, if you wanted to do this on Inspire handheld, this is the teacher notes, but the student version would be there. You could bypass the paper and have it on here. So here's the data, and then create a scatter plot on it. Go ahead and find the regression equations. So and here's finding the percent errors, all that in the prediction at 2022. So all of that is available on Inspire as well. All right. Secondly, now we're going to go ahead and look at some features on some actual data. And so I'm looking at 500-meter speed skating for women. I also have the data for men, so it'll follow very similarly. And I thought it'd be interesting if we had world records and see if there's any pattern in the world records. Can we predict what it's going to be in 2 years or 5 years or whatever? So back in 1931, this woman from Warsaw had a 62 seconds, okay, 20 seconds, 20 minutes in, 62 seconds, and then the following year it dropped down pretty quickly and so on. So I have all this data, and I put this into the calculator by year. And then the result. And if there was more than one in a particular year, I went with the lowest for that year. Um, but I also looked at this and went from 1931 to 37, and then there's a big jump to 1955, and I'm guessing it's because of World War II and its aftermath. So I decided to use the data from 1955 on, okay? And so I typed that data into the calculators, created a program so that, again, you don't have to type it in. Oh, one other thing I do want to point out about the data, and that is notice up until 1970, it's to the nearest tenth of a second, and then with electronic timing, we were able to go to the nearest hundredth of a second. So just pointing that out. So again, let me show you this and how I would hope this went with your classroom. I am going a lot faster, of course, than I would with students because I'm not sure you would have a problem with the mathematics or maybe the technology, but you know, you have the teacher notes and solutions to walk you through it if you want to go back through it. So it says load the program speed FEM into your TI-84 or 84 CE. So I'll click on program and press the up arrow to get to the bottom. Notice I have a speed men for the males and speed fem for the females. So I'm going to go ahead and execute this program. And it says it places the women's skating records from 1955 through 2022 that we have into lists. And it says the time is in seconds in list two. So let me just again go to those lists. Looks like I have some other lists in here. Let me go ahead and clear those out so that you don't get nervous. That was some other things I was doing on here, I guess. So there's the data. And we're going to go ahead again, approximate, get that in a stat plot. And it looks like I still have one on. So I think I like the stat plot that's set up there, but I am going to have to change the window because it's different data. And the one I chose here was going from year 1950 to go back a little bit to the year 2020, which is this year, in steps of 10. And then again, I'll have a negative number for the time, just so I have a space to trace, and maybe 70 seconds showing every 10. So this was my window that I'm going to use. And again, you have this information, okay, in the teacher notes. Y equals, let me go back to y equals and make sure I clear out anything that's there. I don't want any of those old equations, and plot it. And there we go. And so what type of equation or equations could we use to model this? I think it's pretty clear. That's about as linear as you're going to get with real data. Okay, you might could do a quartic if you wanted, but linear looks pretty good. Okay, and so this is where I like to be a little bit different than what some teachers would do, and that is, since it's linear, I'd like the students to go ahead and model it what I call by hand, that is not use any regression features. Just put that in Y1 and then see how good your answer is. Um, let me just pause for a few seconds and consider, you know, what ways I could do this by hand. And what I'm thinking is just maybe pick 2 points, find the slope, find the y-intercept like I would normally, only the data is kind of nasty, okay? Excuse me, but let's go ahead and do that. Let's go ahead and pick 2 points. So I'll go ahead and trace. And what I think I'm going to do is I think I'm just going to use the first and last point. I'm not going to be real clever because I think connecting those might not be too bad. So there's the first point, and then I'll trace to the ending point. And so these are my coordinates that I have, and I want to find the slope of a line that goes through these 2 points. So let me go back to the home screen, and I'll clear that. And let's find the slope of the line containing these 2 ordered pairs. So again, I'm going to need my fraction template, and I'll subtract 36.36 minus 45.6. And then I got to go to the times in the same direction. So it's going to be 113, year 113 minus 55. And not surprisingly, I'm getting a negative number for the slope, which makes sense. This has a rate of change that is negative. It's falling down here, okay? Not very big. So what I think I'm going to do is store that value into a variable so I don't lose it. And I think the value I'll use is the letter M, surprisingly, or maybe not so surprisingly. Okay, question came up, how did I get the fraction template? There are 2 places to get it. One is alpha y equals has the fraction template in it in number 1. And the other way, my favorite is alpha followed by xt theta n. Okay, right next to each other. Alpha xt theta n is the fraction template. Thank you for that question. I'm glad I caught it. Now I want to find the y-intercept. So let me go ahead and add a page to get the y-intercept in here. I've got, maybe I need to go back. I've got the ordered pairs, okay? And I think what I could do is use this ordered pair. So let me copy that, bring it with me. So here's one ordered pair, and I have the slope. So let me go ahead and write a little bit here, do some handwriting. Let me make this a little smaller. So I've got the slope, so I go back to my old buddy, y equals mx plus b. And I've got a y, I've got 45.6. I've got an m, I've got an x, but I don't know what b is. So it looks to me like if I'm going to find b fairly easily, and I'll store that into b. So that's going to be 45.6 minus 55 times the current value of m. And I got all the significant digits. Some of you might want to store it maybe to 3 places or 2 places. That's up to you. And then I'm getting this number for b, and I'll just store that for b. So I don't have to write anything down. So I've got those things right there. So I would like my students to be able to do that. I think that's a reasonable thing, and I like them to be able to use the calculator to do the calculations and to practice in storing numbers into variables and using them. So now what I'm going to do is I'm going to go back to y equals, and I'm going to go ahead and graph y equals m times x, times is optional on this calculator, plus apps, which is b. And so now I'm going to go ahead and graph that and see how good of a fit that is. And looks very good to me. Of course, I made it, so I'm going to think it's very good, but and I think it's really powerful for our students to do that. I think that so they don't just think the calculator is magic and it just pops out with the answers. And that's a pretty good approximation right there. Okay. Let me stop there for a minute. Again, Mike, any questions? Are people still out there?
Hey, Tom. I think the
I
only
don't know
question
why
I saw.
my speaker keeps going off. Let me turn that off. Unplug my speaker. Sorry about that.
No problem.
We're
We
good?
just
Or is there a
had,
question?
yep, just one question that I think would be great to answer if you could is so these programs that you've been using are not preloaded on the 84, correct?
Sorry, Mike, but I'm not getting you. not a good time for a speaker to go bad.
That's okay. Can you hear me now? I'm guessing that's no. Well, while Tom is trying to get a speaker to work, I just saw a question that
Okay, it's
said,
working. Yep.
awesome. So we have someone that has never loaded a program before, and I know that I think all the programs you've been using tonight, for the 84 at least, are not preloaded.
They are, yeah. Well, no, they're not preloaded by the company, but they are preloaded by me. Yeah.
Right. So
So
can
they're
you just,
curious to know how to get those. Is that it?
yeah, I would say more importantly to how to get it on the calculator. I suggested that they maybe use the SmartView software.
I'm sorry.
Hey, Tom, I'm going to change my audio real quick just in case it's me. All right, Tom, let me try that again. All right, so Christopher hears both of us, so that's good news.
Okay. All right. Whatever I did. Okay. Sorry about that. I have no idea why that happened, except that the speaker wasn't working.
No
So,
problem.
you were talking about programs, about preloading or loading them.
Yeah, I just want to know if you could just take a 30 seconds or so and just show how fast and easy it is to get, say, a file from your Bitly. At least, no, we can't do that. Uh, and Samuel, I just saw your question come up. I don't believe that's currently an option, but I will double check for you to see if there's a way of getting the TI emulator on the Chrome notebooks to upload files.
Hey, Mike, I'm not sure what's going on, but I lost my speaker. Okay. All right. So at the end, if you remind me, well, let me turn this off. I'll turn this off. So at the end, if you remind me, I'll show how to hook up the load a program. Okay, I'll show how to show that. Sorry about that. Okay, as long as you can hear me, we're good. Okay. All right. So now I'm going to go ahead and finish this. Instead of doing the by hand, I'm going to go ahead and look at this with a regression feature. And so I'm going to turn off Y1, okay, by tapping on the equal sign. And so the black box is gone. So it's still there, but it's not going to graph. And then I will go to the home screen, and let's start a new home screen here, stat calculations, and I'll do a linear regression. Again, L1 and L2, and I'll put this in Y2. Alpha trace is the quickest way to get to the Y variables, alpha trace, and calculate. And that's a pretty good looking R and R squared there. R is negative because the data is going downhill. And so let me go ahead and graph that. And again, not bad. Okay, not bad at all. So again, by appearance, the data seems to fit pretty well. So we're going to use that equation to answer the rest of the questions. And so let me go ahead and this, to me, this next part is like the key part maybe of the evening, okay? So let me go back and grab that linear regression so I have those numbers. Because what I want students to be able to do is to not only be able to point out what the slope and y-intercept are, but what do they mean in this problem situation? I think it's really important that they be able to understand that. It's the practicalness of mathematics. ACT and SAT like to ask questions like this. There's many, many reasons to do this. So for example, here, M appears to be negative 0.17 to the nearest hundredth, and B seems to be 54.47 to the nearest hundredth. And so what does the slope mean here? And also include units in your answer. In fact, I think the units help you to explain what it is, okay? And what I'm hoping students will say is that the negative indicates that the number of seconds is decreasing, and it's decreasing on average 0.17 seconds per year, meaning after about every 10 years, it's going to go down about 1.7 seconds. Then that's what the negative is. So it's seconds per year on average. Okay. And I think it's really important that they get that. Now, B being 54.47 is a little bit weird in that that's when the time is zero. And remember, we said 50 was 1950. So time zero would be like 1900. And so this would be the approximation with our linear approximation is that that would be the time at 1900, like extrapolating backwards, okay? And we know that that's not true because just in the 1930s, it was already over a minute. And the reason for that is, well, first of all, we didn't do it back then in 1900, but also there was a big gap between 1930s and 1950s, and it's kind of like leveled off. The rate of change has leveled off in the last like 70 years or so. But again, to me, this is the heart of the problem, of the heart of doing this problem, is answering those questions. All right, so it says here in list 3. Now, this is another thing that I like to do with students, and hopefully this is something you would like to do as well. I'd like to go in list 3 and put in the predictions using the equation in Y2. So let me show that. So I'm in list 3, and I'd like to put side by side the predicted values for each of these years. And the way to do that is I'm in list 3. My equation is in Y2, so I'm going to bring up Y2 and evaluate that at these numbers in list 1, second 1. And so at each one of these values, it's going to plug it into the regression equation and come up with an answer there. And now the students can actually compare each year. How good of a fit was it? And for the most part, it is pretty good, okay? In list 4, I'm asking for the percent error for each year. So instead of doing one at a time, we can do them all in one fell swoop. And I think that's really important that students can generalize this from an individual one to being able to do it in all of them at one time. Again, I'm a real big user of using spreadsheets, and this is kind of like using a spreadsheet. So for here, I'm going to get the percentage error. So again, I'm going to bring in my fraction template. It'll be 100 times the quantity of what's in list 3, because those are the experimental, minus what's in list 2, that's the actual, and then divide it by list 2. I'll also take the absolute value of that, my goof, because some of these are negative, some are positive. Negative means it's low, positive means it's too high. So not a problem. I'll just go to list 5 and take the absolute value of list 4. Okay. So absolute value is in window, alpha window. And I'll just take the absolute value of what's in list 4 and put that in list 5. And so now all of my percentage errors are positive. And the reason I did that is because I wanted to, in my next part, I want them to be able to find the mean of those numbers, of those percentage errors. And it's a real good discussion why some students would want to take the mean of list 4, and that would not work because some are negative, some are positive, and they could cancel each other out. But the mean of list 5 would make a lot of sense here. So to do that, under list, there are math calculations like find the minimum of a list, mean, median, and so on. So I think I'll just find the mean of list 5. And what does this mean? This means that on the average, my percentage errors are about 1.64% off each year on the average, which is not very bad. If this was a science class, this would be, well, you probably cheated. And then we can use this to predict what would it be in 2022. So again, I'll bring up Y2 and evaluate it at 122, which is the year 100, year 2022. And we would say with fair confidence that the record will probably be about 34.18 seconds then. All right. I'm going to go ahead and look in the chat and see if there's anything in the chat that I should know about. No, looks okay. All right, so the TI-Nspire part of this, I'll just show the TI-Nspire part. And this is the teacher notes and solutions, already has it in there. But the data is in here, and then I did the same thing where I did the function at the year and did the absolute value of the percentage error and so on. Have a linear model right here, and then found the slope, found the y-intercept, found the equation, find the mean of the error. Okay, all the same things I did with the 84. Here are the regressions showing up. So again, very similar. Just want to be sure that if you're using Nspire, I haven't left you behind. All right. I also have the data for the men's skating 500. I only have the data. I do not have the documents, but the data is in the program. It's also in the Nspire file. Do I have it here? Do I have the other? No, I don't have it here, but it is on the website. It is on the website. It'll put the data right in for you. All right, so you all know what the Olympic logo looks like with the 5 rings. I'm going to model a different logo that I created. I made this up, and then you can do a similar activity using the official Olympic 5 ring. Hold off on that. I might have some help for you on that one. So I created this logo right here, okay? It's 4 rings, not 5, 2 on the top, 2 on the bottom, okay? And I have it stored in circles underscore logo.png. And I put it in the 84, I put it in the Nspire. And so let's go ahead and look at the 84, and the Nspire would be very similar. So, so I'm going to go ahead and run the program. Called Circ logo. You'll notice underneath is Circ solution. It's the same program, but it has all the answers. So you'd have that, so you can see that. And so it should be, the logo should be in image 9. I had to preload that image, okay? Press enter. And now if it says press graph, and there it is on a pair of axes with a grid, okay? And what I want to do is find the equations of those four circles and graph them, and then take away the axes, take away the grid so that I have the logo mathematically. Okay, that's my plan. So I did that part already. So I'm gonna adjust this a little bit. I'd like to make it so that these circles, blue and brown, have their centers right on the x-axis, and move the green and orange down along with them, so that it would be easier to just to do the equations. So I asked them to go ahead and play with um, the window settings, okay, to do it. And if students get really upset about it, I do supply the window settings that do that. Okay, so I'll just go ahead and follow them right now. The X's won't change, left and right won't change. But if I go make this negative 9.5 to positive 5.5 and keep everything else the same, then the circles seem to have their centers on the x-axis. These are tangent to the x-axis. It's a much easier problem now. And what I need to do is, this is where the mathematics comes in. The students are going to have to be able to figure out where the coordinates are of the center and what the radius is and so on. So it says, what's the length of the radius of each circle? So I'm going to go ahead and count maybe the diameter. These are congruent circles, by the way. 1, 2, 3, 4, 5, 6, 7 point, almost 7.5, we'll say 7.4. And so I'm going to go with a radius of about 3.7. And I'm going to store that into R on my calculator, because it's going to make things a lot easier. You don't have to, you can do this with numbers, but the radius is about 3.7. And then it asks to write the equation of each circle in center radius form, which again is some good mathematics for our students. Only now they have a reason to do that, to be able to do this. So if we look at, let's say, the blue circle, it looks like it's going to be x minus a negative 3.7, the quantity squared, plus y minus 0, the quantity squared, equals 3.7 squared. And from now on, what I think I'm going to do is I'm going to write that as x plus whatever is in R squared plus y squared equals R squared, so that I could have less typing to do. And if I look at, say, the orange circle, its center looks like it's going to be the diameter, which is going to be x minus 2 radiuses, the quantity squared, plus y minus a negative 1 radius squared equals the radius squared. Again, I could replace all of those with 3.7s and so on. So now to graph them, keep in mind on the 84, you have to graph two equations. You have to solve for y and then be able to get two equations, a plus the square root and a minus the square root. If you haven't done that, you'll see what I mean in a minute. So for example, let me take this orange one here and move it over. Oops, grabbed the wrong thing. Sorry about that. So I need to solve this equation for y. So I'm going to have y plus r, the quantity squared, equals r squared minus that quantity squared. Take the square root of both sides, and this is where I get the two plus or minus square roots. And then I'll subtract the r, that same thing. And I will do that for all of those equations, okay? For the blue, for the brown, the orange, the green, and so on. I have them all here, okay? And then I need to type them into the calculator, okay? And turn on that turn off the background so that they don't show up. So instead of typing all those in, I think I'll just go ahead and run the program with the answers so that you can see it just for time's sake. I'm hoping you realize I could do that. So I'm running the circle solution one. And now I'll just go ahead and press graph. And now it's drawing my logo, but without the grid, without the axes. Now, the one bad part here is you can see there are gaps. And those of you who have graphed circles on an 84 before realize that happens. Two of the reasons I've heard is one is because of pixels turning on and off. And the other one is the square root. When you get close to 0, sometimes that gets close to a negative number and it won't plot anything. So, but again, this is what the graph equations would look like. Okay, I get everything in terms of R, but again, those R's could all be replaced with 3.7s. Okay, and then you could also just compare those to the original. So I didn't think that was too bad. All right, so the logo or the one with the circle for the student. I have similar things here as what we did on the 84. The only thing is I made it a lot nicer. Let me show you do I have the solutions? Yeah, I have the solutions one. The solutions one is a lot nicer because I made the circles and the grids so that the radius is 3 and the centers are right at nice whole numbers. Okay, so it works out a lot easier on Nspire than it did on the 84. And you can go ahead and draw them, and then you just go ahead and hide the equations, make them thicker, hide the grid and axes, and then change the colors. So it can also be done on Nspire. All right, where are we here? We've got 8 minutes left. So those were the ones dealing with Beijing. These are the ones I thought I would add since I had a couple minutes here. A special weather appropriate activity, wind chill. I wrote this activity a few years ago and researched it and found this chart, wind chill chart. But there's also a function in two variables, which works great on Nspire, by the way. Not so easily on the 84, but can be done. Okay. And so if you're interested in that activity, it's there. I have it for both the 84 and the Nspire. Okay. It says show this, but I'm running out of time. Trust me that it's there. You can look it up. It's easy to see. Another thing I'd like to point out are families of functions. I spent 500 hours creating these 250 plus videos, and they're modular, meaning use whatever you want to use. This is what the website looks like. It's 16 parent functions. Hopefully your favorite parent functions are included there. And each one of these has about 15 videos, whether it's translations, dilations, horizontal stretches, shrinks, vertical stretches and shrinks, combinations of those. There are 6 different transformations and several combinations of them. There are videos on explaining each of those transformations. But here's to me is the essential thing for this. Is there a place where you can download the quick reference guide? That to me is essential to give it to point it out to your students and your colleagues. And so here's one sample one for the squaring function. There are 15 videos listed. There's always an example, at least one that's illustrated, and usually a now you try one, a self-assessment. There's 2 links here, but they're the same place. One is a YouTube and one is a little bit more structured name for one. And here's what I would do. I would say, all right, if you're studying quadratics, say if there's any one equation you can't graph easily, go ahead and watch the video and it'll show you how to do that. So the website, let me just show the website. Oh, and this is the families of functions PDF. You can see it goes on and on. This is the this is the linear, slope videos, quadratic, absolute value, square root. I mean, there's a video behind every one of these. Okay, reciprocal function. List goes on and on and on. So the website I created for you. All of the things I've talked about are here. Okay. Even a link to the PDF of the presentation is right here. I TI Connect software is what allows me to put programs on the calculator and other things on the calculator. Um, and I think I have a minute to be able to show that. So let me try to do that. Um, for some reason, my speaker is not working. I have no idea why. So I'm kind of cut off from the world here. But let me go ahead and run the TI Connect software. It's TI Connect CE, by the way. Whether you have a CE or not, you want to use the TI Connect CE software. And so I'm going to go ahead and go to Calculator Explorer. And I do have a calculator connected to my computer via the USB cable. And it's right here. And this is everything that's on that calculator. So if I wanted to put a program or a file on it, all I have to do is find that program and drag and drop it. And do I have any up here on the screen? I do know where I can find some. Let me go to, so desktop, and I'll just go right to the Dropbox where all of my stuff is. And now it's deciding to take its time. That's nice to do. Oh, no, how about if I just go right here? I'll just go right here. So here I have beige pop. I can go ahead and beige pop, and I can go ahead and drag and drop that program beige pop right onto this calculator. Missed it. So I'll try Circle's logo, copy, and now it's going to say send it, and I'll say send it, and now that program is there. Oh, calculator is busy. Oh, okay. Oh, that's because I was running the smart one, smart pad. Let me try this again. Circle solution, send it. And then I also said I wanted to put the Circle's logo on here. So now when I send this, this is going to pop up and say it's an image. And I said I wanted an image 9. So I'll just click on image 9 and send it. And there it is. It's that easy, that quick to get programs, other files onto your calculator. All right, let me go ahead and tie this up here. So finally, the extra bonus, and this is the website. If you email me within the next 15 minutes, I can send you all the materials for an activity for both the TI-84CE and Nspire that deals with a logo I could not use in my presentation. Wink, wink. So if you type wink, wink in the description, I'll email you back tomorrow with, I guess you can call it O-rings, okay? But it'll be, if you want to model a certain logo, you can do that. By the way, I've modeled logos before. McDonald's is great. Toyota is great, perfect if you're using ellipses. So with that, I'm going to turn it back to Mike and try to read his lips as he finishes up here.
Tom, thanks so much. To receive a certificate of attendance, go ahead and click that link in the chat window. Also listed as a link for the documents that both Tom and I used tonight. And if you're having trouble with these links, just hang tight. You'll automatically get a follow-up email within a couple days. And that follow-up email will contain links to the recording, the documents, and the certificate. And as promised, we're giving away to one lucky winner at TI Graphing Calculator. And tonight's lucky winner is Sonia Olivares. So, Sonia, congratulations. We'll be in touch over email next few days here to get a little more information from you. But congratulations on winning tonight. When you leave the webinar tonight, a brief survey will automatically appear in your browser. Your feedback guides us as we plan future online events, and we really hope you share your thoughts in that post-webinar survey. Huge thanks to Tom for everything he shared tonight. So Tom, if you can hear me, thank you. And since you can't, Tom, huge thanks, and I won't call you any bad names. And thanks to everyone else for joining us tonight. We hope to see you back online next week. Have a great night.